hello Gophers, or in Deutsch, it's hello Gopher and Gopherin. I'm learning Deutsch, trying at least. So yeah, thank you for being here today. Yeah, so let's get started. So I'm Rabieh Fashwall. I'm from Lebanon. Been here in Germany since 3 years. I'm working as a platform engineer at Any9s, and I'm glad to have my colleague here today also. So my story with Golang started in 2018. Mainly I worked before with .NET, C#, and what I liked about Golang is its simplicity. It's really simple language to learn, and yeah, I've fell in love with this language. It was really easy to learn in just 1 week, and in that week I was like talking deeply about Golang with my colleagues, my friends, even my family, and I had to convince my wife that Golang is programming language. So just when I started with Golang with Hello World application, and now as I'm a Go guru, I started to build production code. So I started thinking about error handling. What about state management and concurrency? So things like simplicity hides also some kind of it's not that simple as we think when we go to production code. So error handling. So Golang differs from other languages, how it handles errors, like C# or .NET. So it differs from exception-based handling, and as we have heard from the Go team yesterday, it will stay like that. So how we can handle error effectively in Golang. So we can have error wrapping. We can add more context to errors. So for additional information when we log errors, it's very useful. We have error tracing also when we wrap errors. It allows us to trace errors through multiple application layers. And it also provides rich error information by adding more context to our error logs. And it improves our logging and monitoring, which making it more better. So for example, we have a use case, like I have a client that query user from a specific database. And as we propagate through those multiple layers, we can wrap errors. For instance, at the database, let's go to the code. So I have 3 layers here. Like Golang provides a wrap verb where I can add more context to my errors. And you can see here, we have the W verb. And as I move deeply through the layers, I can add more context. And then when I return to the API layer, I can log error context for internal use and expose only generic error message to the client. So to not expose a lot of information to the user. When error wrapping is too much, it has its benefits, but it also causes overhead. So excessive wrapping can lead to performance degradation and large logs. It also makes readability hard to follow when we look into logs. And too much details can create noise, making it difficult to pinpoint the actual problem when we are debugging our program. And if we see the benchmarking, as we add more wrapping, we get overhead with time and memory overhead. So like we need to wrap selectively our errors and log efficiently, only log things that you think that are useful for debugging, and keep it very simple, communicate clearly, and make the message more user-friendly. Strategic panic usage in Go. So understanding when to panic in Go can be challenging, especially given its potential to disrupt our code flow. So for instance here, I have a function that set up SQL connection. If my connection doesn't work, it will corrupt my application, and I need a way to notify the user that the application is not working. And you can see when, for instance, I miss some critical configuration, data source name, I do panic with a given like meaningful error. And if I fail to open my SQL connection, I need to also fail gracefully. And if I want to, like, while my application is running, I need to make sure if my application is still accessing the database. But then we need to recover from panicking and then perform cleanup or notification for like better problem handling. So when panicking, always use recover in a defer function. Log your panics. Capture log panics to understand what went wrong and to facilitate debugging. Limit the scope of recover. And most important, clean up resources. Ensure that resources like files, network connections, or database are closed. So, but I should warn you because of excessive usage of panic. It introduces like significant overhead with memory and execution time, as you see in the benchmarking. Yeah, just to mention that, like, prefer returning error than using panic, and use it wisely. And if you want to gracefully, like, use os.exit. Yeah. Thank you. Yeah, and use exit function provided in the OS package instead of using panic whenever you need it. So, error comparison efficiently. Like, we can have sentinel errors where we can compare them directly. Also, Go provides two assertions with types, and also where you can find and compare the error type after you are wrapping it for handling specific error types. Because sentinel errors are used for predefined errors like not found, or user not found, file not found, and such kind of errors. The last one is errors.is for checking when you need to verify if an error matches a specific sentinel. So use error.is. So always avoid direct string comparison and use like those two assertion types for error comparison because it will make it's hard when errors change and like later like error comparison will fail when things change and you can't track those changes. Strings. So in Go, strings are immutable, and it's important to handle strings effectively, which involves like iteration and trimming operations. So when working with strings, sometimes we deal with Unicode and often multi-byte. So always use for loop instead of using indexing, because like when iterating through strings, like we need to avoid issues with multi-bytes characters. So for instance, I have here an Arabic word, marhaba, like hello in English. So when I iterate it, like it's messed up when I lock it. So always prefer using range instead of using the index when dealing with strings. Also avoid pitfalls for writing custom functions. Like Go provides, the standard library provides strings package to use. Functions like string.join, contains, trim space, and replace all instead of writing our own functions. They are very well performant. And if you come into like finding bottleneck or performance issue with these functions, you can just like open PR for the Go team to check. And you can see here the like overhead for using custom join functions over using the standard SDK package. Also, when we deal with concatenation with strings, like developers tend to use plus, and it causes really big overhead with performance and memory consumption. So always favor using the strings.builder when dealing with concatenation. You can see here like there is a big overhead when dealing with concatenation with the plus operator instead of using string builders. Avoiding useless conversions when dealing with strings. So for instance, like dealing with network applications when we are fetching bytes. Not sure what happened. I'll get some water. Went out.
Is it just unplugged? Yeah.
The screen's here working.
Wait. Yeah. I don't know what to say, really. Do a joke? What? This is a serious time.
It's a very weird pattern.
I guess we've got the team working on it in the background. Meanwhile, we have some things to give away, don't we?
Yes, we have some pretty keychains.
Yes. So why don't we do that?
Like a tiny gopher. If I run, I can find one and show you.
Okay.
1, I'm not gonna run.
You're not going to run, right? Okay.
I'm gonna go,
Just go. Just
I'm gonna go
You're-
really slow,
Yeah,
so it can everything gets mixed.
yeah. The massive telly's broken.
No, here it's working.
So we need to think of a way to do the giveaway. So I think it's just going to be a case of me harassing you, isn't it? So, oh, there's light. Okay, what is the third argument when you make a slice? I heard it over here first. It was here. So yeah, you've won one. We don't have the merch just yet, but we'll get it. What was your name?
Nipuna.
Sorry?
Nipuna.
Nipula. Congratulations, Nipula. Oh, look, we've got this back.
Oh, thank you. Who won
Nipula won one, so we
Nicola?
should,
Where
yeah.
is he?
He's just there. He said capacity, and then that made him win.
Congratulations.
Okay, we'll leave you in the capable hands again.
Thank you.
Goodbye.
I should have break it before to drink water. My mouth was really dry. So yeah, when using the plus operator, you can see there is a big overhead with time. You can see per operation. It consumes a lot of time and also a big memory overhead. And avoid useless conversions when dealing with strings. If you are working with bytes, just don't convert them to string because it also it also gives time consumption overhead when converting strings. And when you parse strings, like parsing large strings, if, for example, if I am parsing a log, copy the string instead of just taking a small portion of it, because obviously it will stay in memory and cause also memory leaks and memory overhead. So dealing with concurrency, shared state mutation, like modifying shared variables when working with concurrency could cause like inconsistent behavior and can lead to data races. So use mutex instead when dealing with concurrency, and use the lock unlock when updating or reading shared variables. Over concurrency, when we create a lot of Go routines, it will overwhelm the Go runtime. So when dealing with Go routines, use them wisely, and instead of use worker pool to limit the number of Go routines instantiated. For instance, this snippet generated consumed over 7 gigabytes of memory. Instead, use worker pool and limit the number of worker when initializing Go routines. So yeah, one of the use cases, like when you need to manage huge amount of incoming traffic and updating how many times your function is being accessed.
That's what's causing the problem. Is your power plugged in here?
No, here.
Keep going. It's fine. Which one's power? This one. Is that your power?
Mm-hmm.
Okay.
Will you update the video later? You will cut them, yeah? Okay. So context cancellation. For long-running operations, use the context cancellation with timeout. You can specify if the operation is taking more than this time, it will exit gracefully. And yeah, this will allow you also to clean up and avoid long-running operations in your application. Sequential processes use channels for coroutines. Mainly, we are using here a buffer channel when dealing with shared global variables. Also, select statement. When you want to manage multiple channels efficiently. So for example, if you are connecting to multiple network ports and each port should handle concurrently like messages, you can use multiple channels, and you can use select statement to read from them. Sorry. Okay, global state in Go. So, like global state in Go can simplify data access and configuration across your application. But, however, when components share and modify global state, things get messy. So there is a risk for tight coupling, concurrency issues, as we have seen, hidden dependencies, and yeah, poor resource management when your application get bigger. So what are the issues with dealing with global state? We could have memory leaks and resource management. So for instance, there's a global database connection here, and we could end up like with memory leaks when like connecting with this database, and we could end up like with full connection pool buffer, and we don't know why it's failing after time. So instead, encapsulate your database connection pool and using struct and write functions for closing and opening the connection to avoid such issues with your connection pool. Initialization or the dependencies. So when dealing with global state, those variables sometimes need to be initialized. And if we use them before initialization, we will end up with like nil exceptions. So instead, use also structs. You can use a singleton for like setting up a logger, global logger, or pass it to where needed to avoid like nil exceptions when dealing with global states instead. So concurrency and race condition, as we have seen, like when defining a global variable, and so mainly Go is designed for concurrent programming, and when dealing with global cache, prefer using mutexes to access those shared variables, and use like read unlock, write unlock to when you need to manipulate or read this variable. Generics, yeah, no more code snippets, I promise. So, yeah, someone who spent like over 9 years working with C#, .NET, when I started working with Golang, and yeah, after finishing with the Hello World, you start to compare with what you are missing while working with Golang. And one of the features was generics and dependency injection. Because when I started in 2018, generics wasn't released yet. But with time, when I started working with Go in production, it seemed like a good decision that like it doesn't complicate your code. So when reading my code after like 1 year, I still can understand it, while in .NET, with dependency injection and a lot of hidden complexity, it's hard to understand. And as Jonathan yesterday mentioned in the panel talk, generics is already baked. No dependency injection is coming. So thank you for keeping it so simple. But if you want to use generics, since it's available now, so use it when you need to eliminate redundant code. So it shines when you want to work with repetitive code. So for instance, if you are implementing a function to sort a slice for various types, you use generics. Type agnostic structures. So when you want to have like implement a queue or stack, use generics instead of using like interface. And implementing common algorithms, so to avoid boilerplate code. And when dealing with, when you want to do filtering and mapping functions, generics can make it more flexible and reusable. So, but when not to use generics? If you think like adding it could introduce complexity, don't use generics. So use concrete type instead, make it simpler. Like write your code, evaluate and refactor later if you think you can change it and remove boilerplate code. But don't start directly with generics. If it obscures your problem domain, so if it obscures the intent of your code and adding unnecessary layer of abstraction, so always prefer clarity instead of complicating your code. That's what I've learned with Go. If interface is better, don't use generics. Use interfaces instead. Final thoughts. So yeah, there is no single correct way of doing and implementing things. So there are more things to debate. There's always room for continuous experiment improvement. So don't overestimate the value of testing and benchmarking. Go provides great built-in tools for benchmarking to identify bottlenecks and evaluate impact of your implementation. And always remember, like, failure is part of the learning process. Fail fast, learn quickly, and act quickly. That's why we have staging environments. So thank you for your listening, and keep coding. Thank you.